Hi, good morning, everyone. Thank you so much for having me. My name is Vernelle Noel. I joined the University of Florida this semester, so I just wanted to introduce myself to you. So my work is thoroughly interdisciplinary with training in design computation, architecture, engineering, science, technology, society studies, and media studies. And so my work is at the intersection, I say, of the past, the present, and the future, where I find old things in the new, new things in the old. So I examine traditional and the technological practices to understand how they can benefit each other. That is how traditional practices can benefit technological practices today, and how technological practices can benefit traditional practices and cultures, especially those at risk. My work asks questions about how we might repair design, technology, and society. This includes practice, pedagogy, and our publics. And this also includes the relationship and the effects of automation, AI, robotics, etc., alongside human welfare. To answer and explore these questions, I build and I employ tools, technologies, structures, and methodologies. On this slide, on the left, top and bottom, are examples of computational design tools that I've developed to address and prevent the disappearance of a dying craft practice called wire bending using ethnographic methods, you know, programming, etc., um, computational approaches. I developed the tool on the top left, which I named it the Bailey Direct Grammar. And this computational tool describes a dying craft wire bending in the form of shapes and rules. To describe the techniques and steps in this craft, it allows analysis, understanding, and transmission of this knowledge and expertise for education and practice. It externalizes this knowledge that's embedded in craftsmen, which is particularly important when practitioners are dying and or retiring from this practice. So based on experiments and workshops conducted, this tool restores wire bending knowledge, it improves technical knowledge and skill in the craft, and it sheds light on the computational dimensions of the practice. It also affords something very new, which is a collaborative approach to the practice, opening new social roles and ways of engaging in it. Below that is an example of output from a digital design and fabrication software tool that I developed to again continue opening up that practice for participation by computational publics and those interested in computational practices. Experiments and workshops have proven that these tools benefit design practice, pedagogy, and the cultures within which they are embedded, including education through computation and craft and vice versa. In addition to designing and building new speculative tools, I also design and build pavilions and other structures to test my hypotheses on design and technology. In the middle is a photo of a pavilion designed and built using techniques and principles from that craft I mentioned earlier, wire bending, which led to the development of new tectonics for architectural applications. Using computational tools, digital design and fabrication, structural testing, etc., we developed new tectonics to test the craft at the architectural scale. This pavilion demonstrates new opportunities possible if we look into traditional practices and new ways using emerging technologies today. On the right is another pavilion designed and built to look into active bending structures using low-tech, culturally sensitive approaches. We exhibited this structure in Spain last year at the International Association for Shell and Spatial Structures. To learn more about my work, you can visit my lab website at sit-code.com, the Situated Computational Design Lab. I look forward to meeting and collaborating with many more of you. Thank you so much. Have a great day.